framework. This isn't to say that some of the techniques I'm talking about can't be applied to other frameworks, but again, this is kind of the context that I'm coming at it from. So just some background, because Zaya Solutions is kind of a new entity. We're founded by a group of CLAs, and we have a particular interest and expertise in developing large-scale applications. And we pride ourselves in using modular, clean, reusable code that adheres to solid design principles. And together we have over 50 years of LabVIEW experience. So we've been around for a little bit. Personally, I've been using LabVIEW since 2006, and I've been a CLA since 2007. I've been to all of the CLA summits, I think, but 2 of them. And so glad that something like this is continuing, even if it's not a CLA summit, something engaging with this. I've never spoken at one of them before, though, so speaking version. So, all right, so quick overview of the agenda here. I'm going to just go over quickly some of the benefits and challenges of Active Framework. And a particular challenge that I want to focus on is distributing data. We'll go over some standard solutions to that. And then, is there a better way? And the answer had better be yes, or this is a very short presentation. Just a quick show of hands before I go any further. I'm just curious, how many of the people here regularly use Active Framework in building their applications? How many people have used it maybe a few times, but decided I prefer to use something else? Okay. And how many people have never used Active Framework? This is a pretty good mix of all that. Okay. All right, so like I said, I'm going to try to stick, the terminology that I'm using is specific, or not specific, but I'm not trying to bring in some of the other terminology specific to software engineering. I'm trying to stick purely with the LabVIEW jargon, so hopefully people can follow it. We are going to be talking a lot about object-oriented design, so hopefully you have some familiarity with that. So at Zaya Solutions, we don't exclusively use Active Framework. We do use it for a lot of our applications. We think it's good. Kind of call it the Broccoli of LabVIEW, right? In the sense that we think it's a clean, healthy solution for large and complex applications. It scales well and provides great flexibility with out-of-the-box support for handling clones, inheritance, dynamic dispatch, easy ways to kind of extend the functionality, override functions you might want to. And as such, it lends itself well, I think, to solid software design. However, as we've kind of seen from the show in the hands and just a general sense, some LabVIEW developers, for whatever reason, find it unpalatable, or it's not their first choice when they go to develop an application. So why is that? Let's go over some common objections that I hear when people are talking about Active Framework. It has a steep learning curve, right? You can't just jump in necessarily and start using it, especially if you don't have a solid understanding of object-oriented programming. It becomes more difficult. Earlier in the presentation, we kind of talked about this. It can be challenging to debug. A lot of the complexity when you're using Active Framework has been moved. You move it from the block diagram to the project and to files on disk, right? So you can't just go to one place and see, these are all the cases and methods that I'm going to use in this application. And if you're not used to that, it can be challenging to keep that in your head and understand, especially if you're new to the application, somebody else has developed it and you jump in, how the program flows. Related to that, I've experienced this personally. I think it's gotten better, especially in, I think, LabVIEW 2019 and beyond. But if you have a large number of classes, which you're going to have if you're using Active Framework, because every message is a class, right? And especially if you haven't paid attention to your dependencies, and you have circular dependencies, that sort of thing, the IDE can become a lot slower than you might otherwise be used to, especially when it comes to building applications or even renaming classes, that sort of thing. And then out of the box, standard Active Framework messages force tight coupling between actors. I put a star there. We're going to be talking about interfaces, but just when people are first exposed to it, it creates that coupling which you might not necessarily want. Also, I would say that there's room for improvement in the tooling and some of the common functions that would be nice for Active Framework. For example, if you have a method and you create a message out of that, and then later you decide that method needs to be renamed, the renaming process is not extremely clean, right? Those of you who've experienced it, you change the name of the method, you have to delete the message or something. You can't delete it off disk though until you close the project because LabVIEW tries to save it, that sort of thing. But the one that I'm really going to focus on today, a pain point that is moving data through a wide or deep actor framework launching tree. And I think that's something that people, they see this, and we'll talk. Let me show the next diagram. So what I'm talking about here is, this is an example application in actor framework. Each of the boxes there represents an actor. And say you have information, you have a fridge actor, and it's reporting a temperature. And you have displays on another part of the actor tree. You want to show that temperature, display that temperature in those actors. In this example, we have a chart temperature display, a digital temperature display. In order for that information to get to the other side of the actor framework tree, best practices is the message goes up the tree to the root actor, then back down and to the whatever actors or displays it needs to get to. Now, in order to do this, one way to handle this is to create a message at every step at every actor along the tree, right? It keeps things modular. And that's kind of the recommended way of doing it, at least at first. Let's see. But you end up with, again, a lot of classes on disk, which I've mentioned can lead to slowdown in the IDE. You also end up with a lot of not necessarily identical, but nearly identical code. You're sending it to a call or you're sending it to a nested actor. Some additional challenges. As I mentioned before, using the default actor messaging, it forces tight coupling between actor layers, and we'll talk more about interfaces later. In plugin architectures, this can be, moving data around can be especially challenging because the recipients of the data could be dynamic, right? At the time that your application launches, all the actors that receive that data aren't necessarily running. And so how do you route the messages especially if you're using those messages where you need to direct it, use that actor's API? How can you get it there when they're loaded dynamically? So just a quick interlude here. For the purposes of this presentation, I'm only talking about announcements and not requests. So I'm using the terminology that I think Alan mentioned in a post that he prefers, not commands, but requests. So that would be kind of incoming to an actor, telling it to do something, versus announcements, which is either data or status, something that is being sent to be used by another actor. Yeah, and I think it's okay to do this when we're talking about the distribution of data. A lot of times it's relatively safe, and messages can often, like in the case of the temperature example here, kind of go through the tree and remain unchanged. If you have a request and you need to direct it to an actor, don't use this method. This is not what I'm talking about. So you can use interfaces for that. That has another role, but that's not what I'm talking about as far as data distribution in this presentation. So what are some traditional solutions to how to distribute data in an application, right? We've seen the challenge. As I mentioned, you could have many individual messages that do exactly or nearly exactly the same thing. A pro of that is if the data needs to change along its route in the application, you can do that. Every actor has a chance to act on the data, modify it, do whatever it needs to, and then send it along. A con of this, though, is like if you don't need to change the data, which I said was often the case, or at least in my experience it is, you create a lot of additional classes that are doing the same thing, can bloat the IDE, and again, you end up with this code that looks practically identical. And then on top of that, it's easy to mix up, right? If you have a bunch of messages that all send this data, right? And you're using quick drop, which everyone's using quick drop, right? And you drop it down, they have the same name, and you don't realize you're using the message, the send from another actor until later. You get an error like this, it's not supported by this actor. So Yeah, so it has some advantages, some disadvantages. Another solution that people can use to try to alleviate some of those problems is to use a zero-coupled message. Again, not really the suggested way of doing things anymore, kind of, but before LabVIEW 2020, it was a better way of doing things, right? You create an abstract message. So you create one message class, and then I guess the different actors can create child messages from that abstract class, and they can then act on the data in different ways, and you can control the behavior that way. Again, you still, one of the advantages of doing it this way is that you still have strict typing. Maybe I should have mentioned that before. Yeah, so you still have the exact data type that you want to use. However, the problem of many overrides still exists, right? You have to create a child message class that does something different or not for each of the child message classes. And then setup and debugging can be challenging. The origin and routing is not clear. Anyone who's used the zero-coupled messaging, I know when I first started using it, I was very confused by it. It took me a while to kind of understand exactly how it worked, do the dependency injection, that sort of thing. And actually, I'll backtrack here a little bit. In Norm and Darren's presentation earlier, when they were giving examples, they said that maybe Casey naturally thinks about doing stuff in Active Framework. I would say when I first started, I did not naturally think about doing things in Active Framework. It took me a while to understand and embrace it. So kind of what we're trying to do here is bridge that gap, so to make it a little bit more palatable, and for people that want to take advantage of some of its strengths, make it easier for them to start doing that. So another solution then, you don't want to create all these messages, right? Let's just skip the whole Active Framework message tree, right? Let's just send it directly where we want to go. So we can use queues, events, that sort of thing. So rather than, here's our nice tree, we're not going to use the tree, right? We're going to go directly to the display actors or whoever wants to consume the data. You can do that through queues, user events. But when you have multiple transport mechanisms, I think it makes it more confusing and harder to debug, right? Not only that, I think code clarity and readability often suffers. You're saying, okay, I'm getting this piece of information. Where did it come from, right? Did it come via just a standard actor message? Did I come here through a user event? And also competing transport mechanisms can start to lead to problems with, you increase your chances of race conditions, deadlocks, that sort of thing, which I don't think anybody wants in their program. So I think this is the last traditional solution that I'm going to talk about right now, is sharing abstract data through a common method in a base actor. So I think it's pretty common for a specific application, you have an actor that every other actor inherits from. You have some common functionality that you want to reuse. One thing you can do is you can say, like, have a data message that handles an abstract type of data and use that for your different types of data. And then you only have to create overrides if you want to override the default behavior of the data transport, right? So by default, you could have your data being sent up the tree, and then it gets sent back down to the tree via overrides. However, you end up with something like this, where you have a case structure where you have to handle all the different types of data. And again, it's not strictly typed, which I do not prefer. And my colleagues at Zaya, I think we prefer to have strictly typed messages so that it's easier, I think, to catch the mistakes at edit time when you do that than at runtime, right? In this, if you mess up the name of the class or something, yeah, you can have a case to handle that and say, like, hey, unsupported data type, but you don't know that until you run the application. Versus if you have a strictly typed message and you're hooking up the wrong type of wire, you're going to get a problem. It's also brittle to name changes with the particular types of data, right? If you change it on disk, you rename it, and you forget to change this class or this case structure, the name, you're kind of out of luck until you get an error message, hopefully. So, kind of important note number 2 here. I am only talking about announcements where, moving forward, where the data does not need to change along the routing in the active framework tree. So if it does need to change, again, I would not recommend using this particular solution to this problem. So if anyone has any questions, feel free to ask also. I don't need everybody to wait till the end. So we get into the real meat of this now, right? How can we make a better solution, and what would it need to do? So I think the first challenge that a solution would need to address would be to limit the duplication of identical messages where appropriate, right? Not couple actors to one another and use strictly typed messages. Now, fortunately, we have interfaces now with LabVIEW 2020 and beyond. That solves a lot of those challenges, right? Interfaces allow the same message to be used by many actors. Is anybody not familiar with interfaces and their introduction in LabVIEW 2020? Okay, I can talk about it just briefly. Interfaces kind of define a way that classes interface with one another, and they're a type of multiple inheritance that's available to us in LabVIEW now, and each class can inherit from multiple interfaces. So you're not locked to just to one actor only having this one. It can inherit from multiple interfaces and use methods in those different interfaces. Right. Yeah. Let's see. So you don't need this anymore, right? Everything instead doesn't use an individual actor framework message. It uses the message defined in an interface that all of these other actors inherit from. Kind of showing you're no longer coupled. If you're using the standard coupled message between actors, instead of being coupled to each other there, you're coupled to the interface instead. Okay, and again, the interfaces remain strictly typed. You have a payload method for the interface, or at least that's what I call the method that eventually gets called in the do of the actor message. And you define the connector pane. It's a strictly typed thing, so you're not having to look at the name of whatever's incoming or the context or anything like that. You just have the data. All right, so we've solved some of the challenges, but another challenge is how do we know which actors support different message classes, right? Because if you're going to be using interfaces and you're going to be using the messages and trying to direct it to the different actors, you need to know if an actor actually supports that message via interface inheritance. And we need a generic way to test whether any actor can inherit from any other message interface. So how can we do this? This is kind of one of those incubation things where I was reading the actor framework forums, right? And I saw a message from Alan there talking about this. And I had been using two more specific class here, trying to determine if an actor inherited from an interface. That does not work, right? That has more to do with canopy course, the type of wire on the block diagram, and every actor inherits from a LabVIEW object, so of course that's going to work. But if you use preserve runtime class, you can determine whether an actor inherits from a particular interface, and you get no error if it does, you get an error if it doesn't. And so finally, we have these different pieces, right? We have reusable messages that can be used by multiple actors, and we can figure out if the actor supports that. How do we actually get the glue and route the messages to those actors, though, right? So there are two parts to this that I broke it up into. If you had a map, so it doesn't have to be the LabVIEW map, even though those were introduced in LabVIEW 2019, but some way to determine, like, if you have a message and you look up what interface it belongs to, which actors inherit from that interface, you suddenly have a way to determine whether that message should be routed to those different actors. But how is that map populated, right? You can populate the map when actors are launched. So when you launch a nested actor, you have the actor wire itself, which you can use to determine whether it inherits from an interface. And then you also have the enqueuer, which is what you actually need to route the message, right? So instead of just launching a nested actor, and if you do an additional check to see whether it inherits from particular interfaces that you want to forward messages from, you can populate this map, which you can then use later to automatically route messages. How are we doing on time here? Actually pretty good. All right, so what does this look like? right? It's very similar to the previous one. Diagram that's like this. This is our application. Root actor launches. These are data generating actors over here. These are data consuming or display actors on the other side. The fridge has a temperature and it wants to send that data out. So you can send the data, it'll get routed up to the root actor. Once it's in the root actor, you can use the map that I'm talking about to kind of say, hey, which actors support this message and route it to those specific actors. Does that make sense so far? Are people following? Okay. So again, just kind of high level. Every time you launch a nested actor, you figure out what interfaces it inherits from. I guess one thing that I left out here is that you need to define which interfaces you want to forward, contain messages that you want to forward up front. And then when you launch an actor, you see whether the actor inherits from those interfaces. And if it does, you add its enqueuer to the map. And then when an actor receives a message, what it does is it checks to see whether the incoming message is a part of the interface, what interface it is a part of. And if that interface is a part of the list of interfaces which contain the messages that the list of interfaces that you want to forward messages from.
On the previous slide, this is just my ignorance. I'll talk loud. The one that showed the tree, and it was making its way up the tree. Was there?
Yeah, there you go. So, it's clear you have some additional things on the display proxy and the root actor, but you magicked the fridge effective announcement to go up to root actor.
Through the proxy.
Can you talk? Is it like, hey, I'm going to send it to my owner, right, or whatever that's called right now, because I'm a nested actor. I'm going to call it to my caller. Does it automatically go to the root actor?
So I'll talk more about that a little bit later. It does get handled automatically, but it doesn't just automatically go to the root actor. There's a default behavior that happens that sends it through the proxy. And the purpose of this map is I didn't want to just have a very flat actor tree where it just goes up once and down, to show that it doesn't matter if you have deeper trees, you can still apply this method.
Casey, I have a question.
Yes.
So you showed a list of messages to forward. So does that mean that every actor above me in the tree needs to know that message gets forwarded?
Yes.
Okay. All right.
But you do it by identifying the interface that it belongs to.
Okay, but for example, your display proxy would need to know that everything underneath it in the tree, it needs to know what messages get forwarded. It has to have a list somewhere.
All right, so let's just talk about this right now, and I'll come back to maybe the details of how this is implemented. But the way the utility that I'm going to be showing works is that when an actor receives a message, it checks to see, is it in that list of the message belong to the interface, an interface in that list of interfaces which contains messages to be forwarded. If it does a check. Right? If it does not, if the actor that receives it does not inherit from that interface, but it is an interface that contains messages to be forwarded, it forwards it automatically up the tree. On the other side, if it does inherit from that interface, then it forwards it down the tree. Does that answer your question?
Yeah.
Okay. Right, so just saying, every time an actor receives a message, it checks to see what interface the message belongs to, uses the map to say, okay, here are the actors that support that message, let's send it to there. So yeah, how do you actually use this utility? This is available not only through a VI package, but we're making the source code available. I screwed up the permissions on some of that stuff, so it's not working right now, but you will. I am providing a link, and you should be able to eventually, in GitLab, just go to the repo and create a fork of this and do whatever you want. A lot of these VIs that are used in this are dynamic dispatch, so if you want to modify the behavior of how it works, you can. But in this demo, this is how it works. Okay, so all the pieces that you need to start doing this in your own application come in the VI package. And the easiest way to get started using this is we've wrapped up the map and everything into this base class, which is pretty thin. This is the base class, the actor here that I'm showing. And so receive message is where all the magic happens, right? Where it actually does the checks and everything. The only thing that once installed, the easiest way to get to this actor is there's a merge VI, added VIs for the API onto the palette. So if you go to the palette, the Zaya Solutions, Actor Framework Messaging Utility, drop it on the palette, then it'll appear in dependencies in your project. You can just drag it in and use it. But the things you need to do in order to make this work are you need to identify the interfaces that contain the messages that you want to forward, right? So there's a dynamic dispatch VI to do that. And it's called AF message forward. Sorry, not that one. Get interfaces to forward. That's the VI you want to override to specify in an actor which are the interfaces that you support forwarding for. If it's empty, the forwarding is disabled and it behaves just as it did in any other actor framework application. By default, it's empty. You have to override this and provide interfaces in order to do this. And you can do this statically, kind of shown here, by dropping the interfaces directly on the block diagram. And you could do it another way you could do it dynamically, right? Programmatically. You could look up, if you put all your interfaces that you know you want to forward in a specific directory and you want to look for them there, you can do it that way. That way, it works better with plugins or that sort of thing, right? Where they're not necessarily loaded when the application starts, but you want to support them later when they could be running. So there's this base actor, but if you have the same set of interfaces that you want to use over and over for every actor in your application, it's the same interfaces that you want to forward, our recommendation is to use another base actor, like integrate that. So have many people have their own base actors that they use in their application, have it inherit from this base actor, and just create an override of get interfaces to forward, and every actor in your application can now forward this. Another thing you need to do is you need to initialize the utility, right? So you can do this again in something like pre-launch init or any initialization method that you use that's common to all your actors. If you don't want to duplicate the code, you're more than welcome to duplicate the code if you want. And what that does is it just resets the map, and it also then gets the interfaces and determines whether forwarding should be enabled for this particular actor. And then the last piece of this is when you're launching actors, instead of using the normal, where's my laser pointer? The normal launch nested actor, we've included an API that's called launch nested app actor. And all that does is take this and wrap it again with the map populating functions so that you don't have to do it yourself, right? It automatically, when you launch a nested actor, it checks against that list of interfaces containing the messages you want to forward and adds it to the map appropriately. And at that point, all the message routing is done via inheritance and that override that's in the base actor that's included of receive message. Payload method overrides, like for the actor that's receiving the data. If you want to do something with the messages, obviously you have to create your own overrides to do that. I can't automatically do that. And this is what I was saying before. If the actor doesn't inherit from the interface, it forwards it up the tree. If it does, it forwards it down the tree. So just a recap of the benefits here. If you use this, you're using the same actor framework messaging transport method that you use for every other method. You don't shortcut the tree. You can change the routing easily without having to modify block diagrams, right? It's helpful for plugins. It's a small code footprint, right? Because you need fewer messages. You don't need to create a bunch of additional classes. And the root actor also never needs to change to accommodate more forwarding messages. You don't have to have something that knows. Yeah.
Like, so there was a VI that you had to have that said, what are you going to forward?
Yeah, that's not necessarily the root actor, though. That's
Okay. Well, I think the point here is that plugins come in, you don't need to update the root actor. Like the root actor's inheritance doesn't need to change, and once you put in the basic stuff, you don't have to add anything else. The basic forming stuff is in there. You don't have to add anything else to accommodate like 50 more interfaces. It's there for 1 to 50 as many plugins as you want.
Yeah. Yeah, you define the interfaces in one VI and a base actor or something like that, but the block diagram beyond that doesn't need to change in the root actor.
Just a curious question. Have you thought about interfaces that inherit from other interfaces, and how do you handle that? Or does that cause any problems? Or
Yeah.
oh, okay.
Should-
Work through the behavior if there's a runtime class that should automatically forward you inherit.
Yeah, I don't do that in the demo, but I think I've tested that. And,
Okay, cool.
so some future enhancements or features that we're considering is making this utility compatible with Active Framework PPLs. There's some challenges associated with that. So this is not a list of things that are definitely going to happen in the future, but things that we are considering. Another thing of note is that we haven't really tested this on targets other than the PC, right? So whether this works well with RT or anything like that, I don't see why it wouldn't, but I'm not making any guarantees right now. And then another thing that we had considered is having separate maps. So instead of relying on whether the receiving actor inherits from an interface to determine whether it goes up or down the tree, having separate maps for both. But I think after we've thought about it more, if you want to do that, it creates a lot more overhead in the development as far as you have to create a lot more overrides. And so for the sake of simplicity, like I said, one of the benefits is that a developer that's developing an actor doesn't really need to know anything about the routing, about where it needs to go. We'll probably keep it the way it is. So yeah, where to get it? It's available as a VI package on VIPM. You can get the source code here. Again, I have to make sure the permissions are correct before I truly enable that. And we should have a blog post coming on the Zaya Solutions website soon that goes into some of the details that I talked about here, as well as providing an example. And if you have questions about it, you can always email us. Is this readable? Can you guys see that? Yeah. It says info@zayasolutions.com will work. We also, if you go to the website, we're cutting edge social media stuff here. We have a Discord server. So if you want to jump on that and ask us questions in real time, we can try to help you out with that. So, we did pretty well with time. So I'll open it up for questions. And if you guys want to go also, since we have a couple extra minutes, depending on how the questions go, we can go into some of the details of the block diagram, like the received message stuff if you want to. So. Okay. Yeah.
Just a question about the best way to probe or debug the messages.
You mean it's the same as how you would probe, I guess, any other actor framework message? There's nothing different about that mechanism. So, however you would do that would be the same.
So I feel like I would want to like try out using your thing, but the problem for me that I would have is I want my actors to be monitored actors or panel actors.
Yeah.
So I would probably have to at least like modify your thing, make your thing a panel actor, then inherit from it. Like,
yeah, there's multiple layers there. We thought about maybe another thing that maybe I should have added to that future enhancement slide is creating a utility kind of like the monitored actor thing that automatically allows you to insert this base actor in the inheritance hierarchy. We don't have that yet, but that seems like something that could be useful for the reasons that you're saying.
So that was one of my two questions was, can you make it so that that's an interface and then it can be added on? Because I didn't see what you were having to hold on to.
The base actor that's included contains the map utility, the map class.
That's where you're, okay, that's
Yeah.
where you're putting it.
So that's, yeah.
Okay,
So-
the other one is you said when it receives a message, if it does implement the interface, then it's always going to forward down.
Yes. Well, yeah, yes.
So when I override the interface, I'm assuming that that's an endpoint, that it shouldn't be sending the message any further because it's actually implementing a do. Is there a way to just cut it off and say, no, I've done it. Don't send it any further because I am the endpoint, even though I have nested actors?
If the nested actors don't inherit from that interface, it won't be forwarded down.
Oh, you're going to walk through the list of nested actors and check each one of them?
Yeah.
Okay. All right.
I can bring up the block diagram, maybe that. There was another question back there, I saw you.
Yeah, you mentioned a future support for PPLs with this. I was curious what's preventing it right now from working in pack libraries.
Well, we have that base actor. It has to inherit from an actor framework PPL, right? I don't know where that lives on your in your machine, in your project. There's not a standard actor framework PPL location.
So if we take your tool, your actor, and we change its inheritance to our packed library version,
And you want to build your own, yeah,
and then
that's
build
fine.
it, then it would work. Okay.
You might have to change some of, I don't know if the replace with command will handle this. Like some of the inputs on some of the utilities are the message class, right? Because it needs there's a VI that takes in the message class and determines what its interface owner is. So if the replace with automatically switches to the active framework or the active framework PPL version of message.lv class, should be fine. If it doesn't, you may have to manually do that.
Wouldn't you necessarily also have to change your maps too? Because don't they point down and cure as part of the?
You would,
Yeah.
you would
Yeah.
have to change your maps.
The
Good point.
replacement should handle that.
They should.
Okay, cool.
Depends on how well the replace with works. So, oops.
Does this make Stephen Mercer excited or scared?
That's a good question.
So it's something I've considered building. I shied away from it because of I shied away from making it any sort of standard part of the actor framework because it does add the weight of a preserve runtime class call on all the receive messages, and that's potentially a non-trivial amount of weight. I'm pleased to see that you're making progress in testing it because I said potentially. I wasn't sure if it would be a notable weight or not. And I hadn't had time to really benchmark that. So it's interesting there that works, and it works lightweight enough that can be effective on a wide range of apps that you're already playing with.
Mm-hmm.
So in that sense, it's pretty interesting.
Yeah. So this is the override of receive message. Let me see if I can zoom in on this.
What's received message normally look like?
It normally looks like this. Well, is that,
Go to the non-disabled page.
I mean, it just calls the do. So I've kind of wrapped it up here. First thing it does is it checks, is forwarding enabled for this particular actor in its utility? If it's not, it just does the normal receive message. If it is, then it checks the message attributes. And if that message is a part of an interface that has been identified as something to be forwarded, it goes on to this next level here. If not, it does the normal receive message. Assuming that it is a message that should be forwarded, it checks to see, does this actor support that message? If it does, it executes it. That's kind of an independent check. And then the last thing it does is it uses the map to look up the nested actors that support that message and forward it to them. So yeah, then if people want to give it a shot, we're happy to hear feedback, whether people find it useful or not.
So you can forward. Did I read that correctly? That you can forward to an intermediate actor that does not act on the message or implement that interface, and then it'll pass it along.
That's the proxy actor. The proxy actor, if it's going up, if it doesn't inherit from the interface, it'll just automatically keep passing it up the tree. On the way down, the proxy actor would have to inherit from those interfaces.
Okay.
But if you design your interface like the default method to just do nothing, then
It won't do anything
Yeah.
except this forwarding
except
behavior.
for
Okay.
yeah. All right. Extra bathroom time, I guess. Cool.
Did you look into anything like creating a root message class of up message and down message as two separate message types that the messages would then inherit from for their direction to bubble? And I'm not saying this is a good idea or a bad idea. Merely, did you explore down that road?
Briefly, the actor framework message maker provider, you'd have to do something to make it change the inheritance, right?
Right.
So I didn't go too far into that just because that seemed harder than
Okay.
doing this. It's something to consider, though.
Right. It's an attribute of some other event systems in like WPF and Windows and stuff that messages are actually flagged with one of these two attributes. This is an up message, this is a down message. And it's something we've never really needed in Actor Framework, but the automatic forwarding, I'd contemplated whether or not we were going to need a tagging system like that and whether there were any advantages down that road.
So the messages go up the tree and then back down the tree. Does it internally switch the flag when it gets to the root actor? Or
No, and that's the trick, is that they consider the up to be a different message than the down, and the person who's
do
at
you
the
repackage it? As
at the inflection point, they repackage it and there's various pros and cons on that, and that's why I was curious if you'd explored the other option.
Is there a way to do that automatically for all messages without having to explicitly do
It varies by event system.
Yeah. So we have not gotten that far in
Okay.
exploring that. no.
Like I said, I don't even know if it's a good idea compared to what you've got here. I was just curious.
It's easy enough to change the inheritance of a message after it's been created. You don't have to go through the tools for that.
Yeah.
And if you're talking about one message you route over the system, this is an up message, this is a down message. I do it all the time. Well, not that specifically, but I change message inheritance all the time.
Yeah. We're just trying to make it as easy for other developers that may not be as familiar with kind of the ins and outs of using Actor Framework. I think this is a decent compromise for adding these features and not making the developer have to know too much about all the under the hood, how it works, and touching a lot of different code to make it work.
For those of you who remember Dimitri's argument for the other form of interface implementation where you're able to carry actual data and his complex diamond inheritance systems, adding this so that you would actually be able to embed the map in an interface and do the multiple inheritance still, this is exactly the use case. Is when we're talking about wanting to inherit from both monitor actor and this kind of router and all that with a base implementation. That's why Dimitri was making that argument. It also adds, as I said in the last presentation that we did at the CLA Summit, 2 years ago, a significant amount of complexity. And as I repeated in my presentation, we weren't going down that road. But if you're ever interested in why Dimitri was pounding on it, this is the use case.
The last thing I'll say, as long as there are no other questions, that the workaround for that also could be, again, the source is available. You feel free to copy it and just like integrate it directly in whatever base actor you have. If you look at the demo, I don't think it's too complicated. We've tried to keep the API as simple and direct as possible so you don't have to mess with too much stuff.
So one thing I just had the thought with that is you could potentially, right, since you can't have the map, right, you can't use an interface with the map, but you could turn that into an interface and then you could just make the map like a global variable, couldn't you? And then, I know we hate global variables, but if you're defining it once in the base class and it's the same for your whole application, why not make it a global variable and then just use an interface? Just a thought.
You need to have a different utility class that contains the map for each of your actors, a different instance of it. because each one has different nested actors that it keeps track of, right? Yeah, yeah, so you could do that.
So this is kind of a two-part question. One, the searching for interfaces, are you just looping over all the interfaces that you support and then using the typecast to check?
Yes.
So the second part of that question is kind of for Stephen. Is there a better way to search through classes where you want to enable finding a descendant class?
I would like to know that too.
No, and in general, we don't want to introduce such things. In most cases, that kind of type testing is a significant code smell. And so it's actually a really big flag if I'm looking at C# code or C++ code or Java that you're doing type testing. And so we have the tools in LabVIEW, but we don't really want to create, high speed, enable this, because it's usually an indication that you're coupling systems in really, really problematic ways. So no, there's not a better mechanism than what we've got here. And the preserve runtime class is as pretty tight as we can make it on the type check. This is worth looking at further, but he's got it tuned about as tight as I can think of to do it, just looking at the brief code here.
All right, thanks everyone.